So I've taught you arc length, and I've taught you area of a surface of revolution. The next 1, 2, 3, 4, 5 examples are just more examples. I mean, the notes are basically done, but I think it's good to see a couple more examples and maybe try them out on your own. This is where you can do them at home, or do them here if you brought your computer or smartphone, or you can do it as a class and say, okay, let's hit pause on this, let's try this one out, and then you can hit resume and see how I did it, and I'll show it to you, and I'll talk you through it, and you can kind of see if you're following along just as well. So if you want, hit pause now and try it out, then hit pause, unpause, and look at it later. So hopefully you guys hit pause, you tried it out, and you got an answer, and I'm going to do my work to showcase if we both agree or not. Arc length. So I'm going to grab dx dt. That's going to be 2t. I want to square that for my formula, and that's going to be 4t squared. It's one piece. dy dt is 12t squared, but I want to square that whole thing. I get 144t to the fourth. So far, good. Plug into my formula. Arc length is from -1 to 0, the square root of 4t squared plus 144t to the fourth dt. And again, like I said all day today, the formulas are easy. It's can you figure out how to manipulate to solve them. For me right now, I'm going to try and simplify this by pulling some stuff out. So let me do it over here so I have some more room. I'm going to pull out, let's see, I have a t squared in common. And left out of that would be a 1 plus, how many 4's go into 144? How many 4's go into 144? How about 36 of them? 36t squared dt. That's nice because I'll be able to pull that part out. And I'll say this is the -1 to 0 of 2t square root of 1 plus 36t squared dt. Nice! That's going to be a great U sub. It's going to be a great U sub. So you'll be able to do a U sub on this. I'll even show it today. U is 1 plus 36t squared. du would be 72t dt. So I need to divide everything by a 36, and I would say 136 du is 2t dt. So now I can say this is the integral of 1 over 36 u to the 1/2 du. Notice I didn't write in the constants -1 and 0. I kind of left those two places blank because it doesn't involve t's, it's involving u's. So when I solve this, I'm going to get u to the 3/2, 2/3 of this, which is 1 over 54, 1 plus 36t squared to the 3/2. Now I can say evaluated from -1 to 0. Okay? And when I do that, I know it's going to manipulate out to 1 over 54. Let's see, 1, 0, 1 to the 3/2 minus, let's see, plug in -1. -1 is 36, 37 to the 3/2. Okay? Now, when you solve that, you should notice that this answer is actually negative. Okay? So somehow I got a negative arc length. And you might go, what? Yikes. No. Because I'm telling you now, 1 over 54, 1 minus 37 to the 3/2, that is negative. So is there anything that I screwed up with this? Or is there a quick fix that I can do? Okay? Well, realize this. When you talk about integrals, remember, integral from a to b of something equals the negative integral from b to a of that same something. Okay? Arc length cannot have a negative length. But you found the value, it's just negative, so it's not a big deal to just convert this and say, okay, let me make it a positive by either saying this, or you could say if you wanted, and sorry, it just keeps getting smaller. You could say that as well. It's not a big deal. You just basically, it's kind of the same idea of if you were looking for this area, if you find a negative value there, just make it positive if you wanted area. Same with arc length. So that's that example there. So hopefully that one worked okay for you guys. We're going to now look at another example that involves arc sine and natural log. And I'll tell you now, it also involves partial fraction decomp. So again, I think you can set stuff up pretty easily, but it might be hard to manipulate. And on this one, you might have a hard time remembering the derivative of arc sine. So try this one out, hit pause, see what you can do, and then hit resume, and you can look at my example and my work for this. Okay, so now I have right here, x equals inverse sine of t. If you don't remember it, or if you never memorized it like me, I'm going to rewrite this as sine of x equals t. If you remember, you can draw a picture. T1, 1 minus t squared. And I'm going to now take the derivative of this with respect to time. So that's going to be cosine x dx dt equals 1. dx dt equals 1 over cosine x, which is 1 over this. But remember, I don't want just that. I need it always to be the squared version. So dx dt squared is 1 over 1 minus t squared. So that's that guy. Let's see if I can do some manipulation of the other guy. I got y equals ln of 1 minus t squared to the 1/2. Square root is the same as to the 1/2. I'm going to drop that 1/2 for a second because it will make it easier on us when we solve. Remember, with natural logs, you can pull the exponent down. Okay? dy dt is 2. 1 minus t squared, negative 2t on top, which simplifies to negative t over 1 minus t squared. But just like on the dx dt, I want to square this out. I'm going to get dy dt squared is t squared over 1 minus t squared squared. Okay? So now I'm going to put it into the arc length formula. So here comes my arc length. It's going to be from 0 to 1/2. Big square root. 1 over 1 minus t squared plus t squared over 1 minus t squared squared dt. So here comes some algebra skills. I want to get common denominators, so I'm going to put that over here, so I'm multiplying by 1. And when I do that, this turns into 0 to 1/2 square root. 1 minus t squared on top plus a t squared is just a 1 all over 1 minus t squared squared dt, which is now 0 to 1/2 1 over 1 minus t squared dt. Now that's a pretty nice simplified form after a lot of manipulating, but you got to solve that somehow. You have to somehow know how to solve that. Okay? It's not a u sub because the derivative of t squared is 2t and I don't have it in there. You might be able to think through it as an a squared minus b squared sort of thing and do it as a right triangle trig, and that might be able to work out. But I also noticed that 1 minus t squared is factorable. So you might be able to do partial fraction decomp. So I want you to think about it for a second. I'm going to put it on the new page, and we'll dive into it a little bit. Two ways to solve it. You can use trig sub. If you do try that, I'll just let you know you're going to get to a point where you have to do the integral of secant theta d theta. You can look that up, okay? Or you can do partial fraction decomp. Okay? Maybe it's good for you to try both of them. Maybe it's good for you to go with the one that you saw first. Okay? It's all about you in practice. I'm going to do partial fraction decomp. I'm going to say this is 1 over 1 minus t, 1 plus t. Okay? So I want to say this is a over 1 minus t plus b over 1 plus t. Okay? Which is a 1 plus t plus b 1 minus t all needs to equal to 1. You remember some of the clevers. I can say t equals 1, which would eliminate the b, and I would just have a equals 1/2. Okay? And I could also do t equals -1. And -1 would eliminate this guy, and that would make b equal to 1/2. So this whole thing is 1/2 1 minus t plus 1/2 1 plus t. And we're going to integrate that. So we're going to integrate again from 0 to 1/2. I'm going to pull the 1/2 all the way out. We got 1 over 1 minus t plus 1 over 1 plus t dt. Okay. This is 1/2. Here comes lots of natural logs. 1/2. Let's see. The first guy I'm off by a negative, so negative natural log 1 minus t plus natural log 1 plus t. Evaluate it all from 0 to 1/2. Which I'm going to do is 1/2 ln of one big guy, 1 plus t all over 1 minus t, evaluated from 0 to 1/2. And you can plug in. So I'm going to get 1/2 ln of 1 plus that, so that's going to be 3/2 over 1/2 minus ln of 1, which gives me 1/2 ln of 3. So the whole problem again, looking back at it, was find the arc length. Setting up the equation, I think, would have been pretty easy for you guys. The equation part would have been right here. But then you had to get common denominators and simplify a little bit. And from there, you had to decide, trig sub, partial fraction decomp, which way am I going to go? So again, it's coming back to chapter 7 and seeing if you're getting overwhelmed with all of the tricks we've learned with integration, or if you're handling it and going, wow, I've actually learned a lot in Calc 2. So hopefully it's the latter part and you're doing okay with it. I got some more examples here. Find the arc length for the given curve from 0 to 2 pi. Well, this one, with no calc, you should know. It's centered at 0, 0. My radius is a. Circumference equals 2 pi r. So in this case, it should be 2 pi a. That's the answer. I want to show it to you with calc, though. So let's take a look at this. Dx dt equals -a sine theta. And I guess since I said it in terms of theta, I should say dx d theta. But I want to square that, so this gets me a squared sine squared theta. And dy d theta would be a cosine theta. I want to square that, and that's going to be a squared cosine squared theta. I want to integrate it from 0 to 2 pi. the integral of a squared sine squared theta plus a squared cosine squared theta d theta. This is 0 to 2 pi. Well, all of that gets me as the square root of a squared d theta, which is the integral from 0 to 2 pi of a d theta, which is a theta from 0 to 2 pi, which equals 2 pi a like we said. And you probably love this problem the best because it happened super duper quick within 1 minute. But again, it's just nice to always show why the geometry stuff you learned a couple years back truly works out based off calculus. Okay? So, next one. Look at this. Wowzer. I got some animation going on in this one. It says find the arc length for the given curve on the interval, and it's of the involute of a circle. And you're going, what in the world is an involute of a circle? Well, an involute of a circle is the green spiral that's coming outside of that red circle. A good way to think about it is think about unwrapping a tether ball. So if you unwrap it around a red cylinder, okay, think 3D, the more you unwrap it, the further away from the pole it gets because it has more rope available. And so it starts right away close to the pole, but the more you unravel it, the more rope is available, and so it spirals out. Okay? So the whole thing is I want to find it from 0 to 2 pi. Okay? So I want to kind of walk it around once. And if you watch this, just on this one, this is just an example. Watch as it walks around once. It starts and stops about there. If you look at that again, it's gonna repeat. But look, start. There's the whole circle once. So it walked around once. So I want to find that length. Okay? dx dt is not dx dt, it's dx d theta. That's okay, quick fix. dx d theta is negative sine theta plus product rule. So product rule would be sine theta and plus theta cosine. So again, testing some of your calc skills. So that's dx d theta just drops down to theta cosine theta. And I want to square that, and I get theta squared cosine squared theta. And I want to do dy d theta, which is cosine theta, product rule. So depending on how you do it, you could say this is negative cosine theta. Derivative of cosine is negative sine, so that turns it into a plus theta sine. So dy d theta is theta sine theta. But I want to square that, and I get theta squared sine squared theta. Doing the arc length now from 0 to 2 pi of the square root of both of those squares. Which is nice that it drops again down pretty quickly to theta d theta, which is pretty easy to handle, which is 1/2 theta squared from 0 to 2 pi, which is 1/2 4 pi squared, which is 2 pi squared. So that would be the length of that. Now again, this is just an example, this spiral that I'm giving you, but hopefully this helps idea on that. Which is kind of cool to think of a tether ball unwrapping into a spiral and being able to find the path it traveled. Think of it as like an orbit. How far did it travel via an orbit around the pole as it spirals out of control? Okay, so a kind of a neat little thing, especially a cool new word, involute. Okay, let's look at another example, which is our last example. Okay, this one's the area of a surface generated using a curve. So I'm going to take a look at this one, see if we remember the formula. I need dx dt, which is t squared, But I want to square that, which is t to the fourth. And I have dy dt, which equals 1. I want to square that, which equals 1. Okay. I'm going to set up the formula for the area. 2 pi on the outside, from 1 to 2, square root t to the fourth plus 1 dt. And remember that I want to revolve it around the y, so that means I need the x on the outside, which is 1/3 t cubed. Remember, it's always the opposites on that. Okay. That's the setup of the equation, and this one should flow pretty quickly because it's a nice u sub. Okay. I can set this up as, let's see, 2 pi over 3, 1 to 2, t cubed, t to the fourth plus 1 dt. Okay. The derivative of t to the fourth is 4t cubed. So I'm off by a 4. So doing it mentally, I'm off by a 4 on the bottom, so I'm going to have a 1/4 there. And later I'm going to have to put this as t to the fourth plus 1 to the 3/2. So I'm going to flop out that, and that should be a 2/3 there. You can check the work and see if you're feeling okay with it. You should see that the 3 over 2 would cancel the 2 over 3 if you took a derivative. The t to the fourth part, when you take that derivative, you're going to get 4t cubed. So the 4 and the 1/4 would cancel. And I've always had that 2 pi 3 on the outside. So that looks pretty good to me. I'm going to evaluate it from 1 to 2. Let's just combine some clumpage here. 2 times 2 divided by 4 goes away. I got pi over 9 times, let's see, 2, 4, 8, 16, 17 to the 3/2 minus 2 to the 3/2. That looks good to me. There's no negative in my answer, so that's going to pair up nicely, and there you go. So I hope you do agree with me that the formulas are easy and nice. It's not a big deal knowing an arc length formula and the area of a surface of revolution formula. It's just really, do you know your skills on integration by parts, partial fraction decomp, trig sub, trig identities, algebraic manipulation? That's where it really gets you. It's kind of where you assume you know all of those skills, and I would just teach you the formula and say, all right, there's the formula, let's go practice some integration. So that's kind of a preview, by the way, of what Calc 3 is like. A lot of times in Calc 3, I will set up the integral that needs to be done, and then I'll just assume you know how to do it. I'll set up the Calc 3 integral, and then I might leave some space and say, hey, maybe at home tonight, practice filling in the rest of the notes. Because we have to start assuming you know how to do the stuff you've learned. So hopefully tonight's homework assignment is some good practice on doing some integration skills and integration techniques. So here's the homework. It will be, you took about 50 minutes for the lecture, so it probably took you maybe an hour to get everything set up and listen to the lectures and maybe hit pause and have some good conversation on stuff. So you probably have 30 minutes or a little bit less time left in class that you can actually work on this and work in groups on this. Hope all is well. Enjoy the 3-day weekend. Be safe at prom if you're going. And I will see you on Tuesday. But you will hear from me on Monday when you have the sub and you're going to be watching another video. Mr. Callahan will also show you where those videos are on YouTube. So if you ever want to get ahead or if you want to watch them on your own time, he'll let you know where those are to be found as well. Thanks again. See you soon. Bye.